Hey everyone, it's Miss B. So we're going to do a practice problem involving finding the area between curves and calculating the volume of a solid. So in this example, this is 2010 Form B, FRQ number 1, and it is calculator active. Okay, so this FRQ is 3 parts. The first part is asking us to find the area of the shaded region, or the area between the curve y equals 4 ln of 3 minus x, the horizontal line y equals 6, and the vertical line x equals 2. So this vertical line x equals 2 is really just giving us this boundary when we're setting up our integral so that we know what our limits are. So we're going from 0 to 2. Okay, so let's set up part A, finding the area between the two curves. So just remember in doing that, we take the integral from 0 to 2, and we're going to subtract the upper curve minus the lower curve. Alright guys, so setting up that area, we have the integral from 0 to 2 of the top curve minus the bottom curve, so that would be 6 minus 4 ln of 3 minus x. And you just have to type this into your calculator, then you're done. So remember, make sure you know how to do that, Math 9. Type it in. You should get approximately 6.816 or 6.817. Both are acceptable. Okay, so that's our area. Alright, so part B, we're asked to find the volume of the solid that is generated by revolving this entire area around the horizontal line y equals 8. So you're trying to think about how would this look if we are going to revolve that entire shaded region about the line y equals 8, which is somewhere up here. Okay, so you want to think, is there going to be a hole? Yes, there's going to be this cylinder here. So picture the line y equals 8, and we're revolving this around that line y equals 8. So there's going to be that cylinder, that hole right through the middle. So we're going to be using the washer method. So you know that you need to figure out your outer radius squared minus your inner radius squared. So before we even set up our integral, you want to think about these things. What would my outer radius be versus my inner radius with relation to the axis that you're revolving around? My outer radius is going to be from the line y equals 8 down to the outermost part of the solid, or the curve, which is 4 ln of x minus 3. That's my outer radius. That's the big R. My little radius, which is just this cylindrical tube here that's going to form, that comes from 8 minus this upper curve here, which was just 6. Okay, so let's see what this is going to look like as an integral. So now that we've identified that our outer radius, our largest radius of that washer, is 8 minus 4 ln of 3 minus x, and then our inner radius, the little radius that's going to create the hole through the washer, is simply the line y equals 8 minus the line y equals 6, so 8 minus 6. Okay? So now let's remember when we are finding the volume, it's simply pi times the integral from 0 to 2, those are our limits still because we're going along the x, of the outer radius, which is 8 minus 4 natural log of 3 minus x squared, minus the inner radius squared. So 8 minus 6 squared, you can just write 2 squared. And again, this is a calculator question. So just go ahead and make sure you have all your signs correct. Make sure you have your limits from 0 to 2 correct. And make sure you don't forget to multiply by pi. So your final answer when you type this into the calculator is 168.179 or 168.180. So this is after we've multiplied by pi. Alrighty, let's move on to part C. Okay, so in part C, they want us to find what the volume would be of the solid that's formed if we picture that this area, this entire shaded region, is the base. And then the solid has cross sections perpendicular to the x-axis that are squares. So if I take a slice of this solid, each of these slices are squares. Okay, so there's a slice, there's a slice. If we keep slicing this, all of those squares, we have a little square, a bunch of medium squares, a bunch of larger squares. So all of these squares, areas, added up, aka the integral, from 0 to 2, is going to give us the volume of that whole solid. Okay, so the key is we need to know what the area of those squares are. So how do we identify the area of a square? We just need to know the length of one side of the square. So if we know the length of one side of the square, you know that the area is simply just that side squared. Okay, so think about what the length is of this square. In this problem, it's simple. It's that top curve, which is 6, minus that bottom curve, which is simply 4 times the natural log of 3 minus x. So that's going to be the length of each side of my square. 6 minus 4 times the natural log of 3 minus x. So now I know the area of that square is simply the length, I'm going to label it S, the length squared. So now let's set this up as an integral. Okay, so since our cross sections are perpendicular to the x-axis, you want to make sure you pay attention to that in the problem. We know that we're integrating along the x. So we're still using the same boundaries from x equals 0 to x equals 2. However, that would be different if they gave us cross sections perpendicular to the y-axis. And I can do a quick different example of that scenario. So this is the integral from 0 to 2 of the area of the cross section, which was that square. So the area of that cross section, which is 6 minus 4 ln of 3 minus x squared. Remember, this simply came from the length of the side of the square. So this was just one side of the square. Okay? So, calculator active, we're just going to go ahead and type this into our calculator and it will do the work for us. So the integral from 0 to 2 of 6 minus 4 times the natural log of 3 minus x, all squared, is going to give us a volume of 26 and 266 thousandths, or 26.267. Those would both be acceptable. Alright, so as I said, I would try to show you an example where we would have to change our integration limits in y instead of x. So this would be if we are revolving a solid around a vertical axis. Okay, so if we're taking a solid and rotating that or revolving that around a vertical axis, then we're going to be integrating along the y-axis. So we're going to be integrating, our limits are going to change to the y's. Also, if we're taking slices that are perpendicular to the y-axis, all of these slices perpendicular, we're adding them up along the y, which means we're going to change our limits to, again, y. So the example I'm going to do is very similar to the one we just did. This is coming from the 2008 Form B test, and it's question 1, which means it is calculator active. Alright, so you guys are pretty good with finding the area between curves, so I'm not going to go over finding the area between these two curves. You know that you just need to find the intersection where these two intersect, and I mean you can visualize what these curves would look like and how they might intersect each other here. Okay, and you can see that they intersect at the point 9, 3. All right, and so I'm going to just focus on showing you how to set up B and C. All right, so quick sketch of what's going on here, roughly. They want us to figure out the volume of a solid that would be formed if we take this region and revolve it around the the vertical line, x equals -1. Okay, so we're going to take this thing and we're going to be revolving this around that line, x equals -1. And so we're going to be integrating here along the y-axis. So we're integrating along the y-axis. All of our slices across here are going to be these circles, right? But remember, we're going to end up having a hole as well. Okay, so when we revolve this, we have that outer solid, and then we're going to also have that inner region that's going to be created, and that's going to be that washer. All right, so let's integrate along the y and figure out the volume of that solid. So remember, it's pi times the integral from 0 to 3 of the outer radius squared minus the inner radius squared. So that outer radius here, if you take a look at this highlighter, is going to be from this outermost curve. The outermost curve in this case is the linear one, is the line. So the outermost curve minus the axis of rotation. So the outer curve minus, what's the axis of rotation here? It's -1. So the outer curve minus -1. The outer curve, 3y, minus -1, so +1, squared. That's my outer radius squared. Now we're going to subtract out the middle, the hole. So we have to do the inner radius squared. So the inner radius squared is formed from this inner curve minus the axis of rotation. So the inner curve minus the axis of rotation. My drawing is horrible. I'm so sorry. This should be like this far away. So the outer curve minus -1 was that outer radius. The inner curve minus -1 is the inner radius. So this inner radius here would be the y squared minus -1, so +1 squared. Okay, now remember this is all with respect to y. So we're going to go ahead and type that into our calculators, and the volume we get is, it's 207 pi divided by 5, which is about 130.061. All right, part C. All right, guys, last but not least, part C, we have to find the volume given the fact that the known cross sections are perpendicular to the y-axis. So we have our slices perpendicular to the y-axis. So all of these slices perpendicular to the y-axis, if they are all added up and accumulated along the y, we're going to get the volume. So think about each of these cross sections is a square. What would the length of the square be? Well, it would simply be this outer curve, take the right curve, minus this lower curve, or the left curve. So the outer curve is the linear one, so it would be 3y, minus that inner one is the y squared. That's the length of each side of our square. Since that's the length of each side, you know the area of your square is simply that squared. So 3y minus y squared squared. Okay, so all we have to do is integrate this along the y-axis from 0 to 3 of the area of the squares, and that just looks like this. The integral from 0 to 3 of 3y minus y squared, all squared, and this is with respect to y. That's going to give us our volume. So you type that into your calculator and you get about 8.1. All right, and that's it for today. Hope this helped.